Hello everybody, today I'm going to explain the solution to the first problem from the silver division, the problem the best lineup. In this problem we are given an array of n cows, and in this array we are performing the following algorithm where we iterate through the numbers in the array A, and we can choose for each one of them whether we add it to the back of the array B or not. And we want to construct such an array B, which is the lexicographically greatest. But in order to improve our answer, we have the possibility of let's say adding moving one cow from a place in the array to something at the front of it, something to the left. And now the goal is for us to find the largest lexicographical array we can obtain as part of processing this sort of algorithm. And in this problem, again, it's very interesting to notice that this trend of making sure that nobody is cheating continues, as we see here again one of these really small texts which doesn't show up on the light mode in the browsers, and basically I think it's a way for them to detect if people use the large language models to cheat. But obviously we are here to learn how to solve the problems legitimately and how to actually become better at USACO without having to rely on AI models to solve the problems. And now in order to solve this problem, we want to start with the algorithm we use in order to construct this sequence B. And now, ideally, let's assume for a moment that we can't move anything to the front of the array, because with that we want to now get to a situation where we know how to construct the array without let's say the extra operation. And obviously if we want to go number by number, then a very easy algorithm which constructs the optimal answer, assuming we don't have the possibility to move anything, is to consider always the largest number we have in the array. And obviously if there are more such numbers, to take the largest one to the left. And you take the largest number and you keep doing that until you get to the end of the array, the largest number among the remaining positions. So in the first example, you would start with 4, then you would look at the largest number from here and you would see the 3, and then you would look at the largest number from here and you would see again a 3. Very similarly, for this example, we would get 6 followed by 4, and here we would get 4, 3, 2, 1, 1. As you notice, for some test cases, it's enough to just run this algorithm and you would probably get the optimal answer even without considering the possibility of any potential improvements. But obviously we want to be able to use the improvements in order to get to the answer. And now, how do we go about improving the answer? Because this is now the most important part, and we need to find some meaningful idea on it. Now, as you see, now an obvious case we can observe from the second sample here is that if the largest number doesn't show up at the beginning of the array, you must move it, because uh, uh, if it doesn't show up and you can get some sort of an improvement, then you can move it like you see here. Like for example, with this 6, if we had it before the 5, we would also be able to have 6 followed by 5. And now this gives us the intuition to start with the numbers which belong to the original, let's say, sequence we print. So if we go by this sort of sequence we have, so 5, 1, 2, 6, 3, 4, we know that 6 and 4 belong to the array belong to the array itself, belong to that original array we would have had to print. And now I'm going to make a claim that it will always be optimal to move something which belongs to this array somewhere to the front. And this claim can be proved pretty easily by contradiction, because if a value wasn't already the maximum according to this algorithm we came up with earlier, then moving it to the front will never make it become a better value. Like, for example, this 3. This 3 would have never been printed, and even if you move it to the front, it will still never be printed. So now we can focus on each number and basically focus on what we can do if we move it somewhere more to the front. And now if we were to have add, let's say, another number, let's say that we would have had a 7 as well, and we move it here, then the question now becomes for each number whether we can move it somewhere more to the front in such a way that besides printing it, we also end up printing something else that is better. And it turns out that all we have to do is for a number to check whether in the set of positions to the left of it, but after the other maximum, there is something which is greater or at least equal to the other number we would have printed, in this case to the 4. And the reason why this works is because we want, in order to improve the maximality of our answer, we want to be able to perform the move as much to the left as possible. And as you see here with this 6, if we move it right after 7, there is no point in moving it or making like a half measure move. If we move it right after the 7, we would get something like 7, 7, 6, 5, 1, 2, 3, 4. And if we run the algorithm I mentioned at the beginning again, we would get 7, 6, 5, 4, which is the largest such answer. And now if you notice, because this 5 was greater than the next number in the sequence, we will also print 5. And now once we find such a number, which is enough, all we have to do is to basically check the maximum in the range between two adjacent number in this sequence. All we have to do is to basically check whether we have this maximum, then just run again the algorithm on that sequence and then print the rest of the interval. And let me show you how I coded it. So I started with computing the suffix maximums. So again, I wanted to always identify the maximum numbers in the array. Then run the algorithm once for the initial array. And then here what I had to do was to check what is the next maximum. What is the next maximum we would have printed. Then compute the maximum number among the values between these two positions. So basically, if we move the current value somewhere before, then we will want to find the maximum between the previous position and the current one. And if this maximum is greater than the next maximum, here I use this array to print. And the reason I use this array in order to print the final answer is because in USACO, there is this error they have with the checker, and I want to make sure that I don't print by any chance an additional space. So I just added the initial maximums, then I computed again the suffix maximums for that subarray. Then I ran again the algorithm for the array in question, for the subarray in question, and then here I add all the subsequent maximums. And here, as you see, I finish the algorithm and I keep this sort of counter which tells me that I actually created an array I can print. If not, I just add whatever the original array was going to be. and then print again the sequence by also making sure that we don't run into errors related to spacing and all that stuff. And as you see, this is one of these problems which has a more ad hoc theme, but at the same time, it's also a problem which forces us to think at simplifications which are then used in order to compute the answer easily and without difficulties. If you enjoyed watching this video, please like the video, subscribe to the channel and press the bell button in order to stay tuned to everything I make in the channel, every video, be it for USACO or for other competitive programming contests. In addition, if you have any suggestions on how can I improve my videos, I would be delighted to hear them in the comments, and I always reply to every comment to make sure that I reach out to everyone who is watching the videos and gives me relevant suggestions. Last but not least, if you or someone you know is interested in improving their USACO results, either for the US Open or for the longer term by looking at the next season, you can check out my website for ways to join my tutoring program, while also checking my new project where I upload my solutions to various USACO problems. Until the next time, good luck in the remaining USACO contests and see you in my next video. Also check out the videos I made on the bronze division. Cheers!